Bismillah ar-Rahman ar-Rahim. In the name of Allah, the most merciful and the beneficent. I am Muhammad Qasaza, and today I am going to deliver lecture number 10 of chapter 12, Current and Electricity. The first article is factors upon which resistance depend. In this article, it is described in a very beautiful way that a resistance is directly proportional to length and a resistance is inversely proportional to cross-sectional area. Resistance increases as the length of a wire increases, and the resistance decreases as the cross-sectional area of a wire is increases. So by comparing these two equations A and B, we get R is equal to rho L over A. So this rho is a constant of proportionality known as a resistivity constant, and basically the resistance of wire also depend upon nature of material and also directly proportional to the temperature. In next slide we will discuss about the effects of a temperature on resistance and resistivity. First of all, we will talk about temperature coefficient of resistance. So in case of a temperature coefficient of a resistance, the increase in temperature is RT minus R naught is directly proportional to the initial resistance. So RT is a resistance at a temperature and R naught is a resistance at a 0 degree Celsius. So in the next slide, this change in resistance at a temperature RT minus R naught directly proportional to temperature. So by comparing these equations, RT minus R naught directly proportional to initial resistance R naught and RT minus R naught directly proportional to T. By comparing these equations, we get RT minus R naught directly proportional to R naught T is so this equation becomes RT minus R naught is equal to alpha R naught T. Alpha is a coefficient of a resistance, so alpha is equal to RT minus R naught, and R naught T divide on second side. So this equation becomes alpha is equal to RT minus R naught over R naught T. Now we will talk variation of a resistivity with respect to temperature. Similarly, the increase in a temperature is RT minus R naught. Here RT minus R naught, we use resistivity rho T minus rho naught is directly proportional to the initial resistivity. So rho T minus rho naught directly proportional to rho naught, and thus rho T minus rho naught directly proportional to temperature. Now comparing these two equations, we get rho T minus rho naught directly proportional to rho naught T. Similarly, we get alpha as a constant of a proportionality, and this constant of proportionality is also known as a coefficient of a resistivity or a resistivity. This alpha becomes equal to rho T minus rho naught over rho naught. On extreme right side table represent the resistivity of different metals. Copper 0.0178, aluminium 0.0285, 114, silver 0.0163, brass 0.062, 0.09, iron 0.1, lead 0.219. So in next slide, there is a difference between specific resistance or resistivity, conductance and conductivity. Step 1 is a definition. Definition of resistivity is resistance of a material offered by a 1 meter length of a wire with a cross section area of 1 meter square. So its formula is rho is equal to Ra over L, and its SI unit is ohm meter inverse. This SI unit is derived from formula. Similarly, for conductance and conductivity, reciprocal of a resistance in a conductor is known as a conductance, and its formula is G is equal to 1 over R, and its SI unit is G is equal to ohm inverse. It is also known as mho. Step number 4 represent diagram of both resistivity and conductance as well as also conductivity. Step number 1 of a conductivity is reciprocal of resistivity, and its SI unit is equal to ohm inverse meter. That is also known as mho meter. Its formula is sigma is equal to 1 over rho. Rho is a resistivity. This was the total lecture, and all these questions are very important according to the paper point of view. Okay ji, please subscribe my channel and like it as well as share it with your friend, family and friend zone. Thank you. Assalamu alaikum.